In the massive, invisible world of the internet, there's a new kind of war going on. And it's not being fought with soldiers, but with algorithms. Not on battlefields, but inside the very web apps you and I use every single day. This is the story of a new arms race, an AI arms race, between code that's designed to attack and code that's designed to defend. And believe me, it's already changing everything.
So, let me ask you something. That banking app on your phone, the social media site you're probably scrolling right now, the online store where you just saved your credit card info, are they really secure? We all like to think they are, but the truth is, the whole game has changed. The threats are just different now. For years, we've been relying on what are basically digital security guards. We call them vulnerability scanners. Their job is to patrol our applications, looking for weaknesses that we already know about. But the problem is, these guards have a huge blind spot, and it's getting bigger every single day. This slide really just lays it all out, doesn't it? On one side, you've got the old guard, scanners that are totally static. They follow a fixed rulebook, they're predictable. And on the other side, you've got the attackers. They're creative, they're unpredictable, and they're constantly rewriting the rules. They're not just looking for known flaws. They're finding clever ways to exploit the very logic of an application in ways that no simple checklist could ever see coming. So here's the bottom line. We're showing up to an intelligence battle armed with a checklist. It just doesn't work. These static, predictable defenses are completely outmatched by dynamic, intelligent threats that are always changing. It's a game we are set up to lose, unless, of course, we change how we play. So how do we fight back? Well, we give our security guards a brain. We stop relying on that fixed checklist, and we start teaching our defenses how to actually think. And this is where machine learning, or ML, completely changes the game. The best way to think about it is like training a detective. You don't just hand them a book with pictures of known criminals. That wouldn't be very useful, right? No, you show them thousands of examples of shady behavior, of inconsistencies in stories, until they develop an intuition. They learn to recognize the pattern of a lie, even if they've never heard that specific lie before. That's exactly what we're doing with AI and security. And this is basically how it works. First, you feed the machine a ton of data, tons of web traffic. Some of it is totally normal, some of it is malicious, like SQL injections where hackers try to trick a website's database. Then the AI just crunches through all of it. It's not looking for specific code, but for statistical patterns. Stuff like how often certain keywords appear, the use of special characters, the overall structure. Over time, it builds this super sophisticated model of what an attack feels like, and that allows it to spot brand new threats that it has never ever seen before. Okay, so that's the theory. Sounds pretty cool, right? But how well does this digital detective actually do its job in the real world? Well, some researchers put this exact idea to the test, and honestly, the results are kind of mind-blowing. So they took 7 different machine learning models and just unleashed them on a whole dataset of these SQL injection attacks. They measured 2 really important things. The first is precision, which basically asks, when the AI flagged something as an attack, was it right? And the second is recall, which asks, of all the real attacks out there, how many did the AI actually catch? The results for precision were, well, they were perfect. 100%. Just look at that first column again. For all 7 models, precision was a perfect 1.0. That means there were literally 0 false positives. Every single time one of these AIs cried wolf, there was actually a wolf. Now, if you've ever dealt with traditional security alerts, you know that is absolutely incredible. No more alert fatigue. And it wasn't just precise, it was seriously effective. The best model they tested, called AdaBoost, had a recall of over 96%. It found almost every single real attack in the entire dataset. This isn't just a small step up, it's a huge leap forward. But, and here's the twist, what if we use that same intelligence to attack? This is the other side of the AI arms race, and this is where things get really interesting. Security researchers realized, hey, if an AI can be a brilliant detective, it can also be a brilliant safecracker. We can use AI to build automated tools that don't just follow a script, but creatively hunt for holes in our own applications before the bad guys do. A classic way of doing this is something called fuzz testing, or fuzzing. The idea is just brilliantly chaotic. You basically bombard an application with a fire hose of junk data. Messed up inputs, random characters, super long strings. You just throw everything you can at the wall to see what sticks. or more accurately, what breaks the application. It's a great way to find bugs you never expected. But traditional fuzzing is, well, it's pretty dumb. It's like that old saying about a million monkeys at a million typewriters. Yeah, eventually they might write a masterpiece, but they're going to produce a whole lot of garbage first. This is where AI flips the script. Instead of blind fuzzing, we use evolutionary fuzzing. It's less like a monkey and way more like a scientist in a lab, intelligently breeding generations of superbugs specifically designed to find a system's weakest point.
This whole process basically mimics natural selection. It's survival of the fittest for cyber attacks. You start with a population of basic attacks. You test them out and measure their fitness. Like, did the application give an interesting response? The most successful ones get selected to breed. We combine their parts, that's the crossover, and randomly tweak others, that's mutate, to create a new, stronger generation of attacks. And you just repeat this thousands of times, evolving more and more potent ways to break the application.
So, where is all this headed? What's the end game here? Well, it's leading us to a future where cybersecurity is no longer about humans setting up static traps. It's becoming a high-speed, dynamic battlefield fought entirely between competing AIs.
All right, let's just zoom out for a second. What have we learned? First, the old rulebook for security, it's obsolete. We've seen that AI can be a nearly perfect defender, a digital detective that's almost never wrong. But we've also seen it can be a relentless attacker, an engine for evolving new flaws. And that brings us to the big conclusion. This is the new normal, a perpetual arms race between offensive and defensive AI.
We're moving towards a world of autonomous agents. I mean, imagine an AI system that can discover a brand new, never-before-seen, zero-day vulnerability that's a flaw no one even knows about yet, then create an exploit for it and launch an attack, all without a human lifting a finger. At the exact same time, defensive AIs will be working to detect these crazy new attacks in real time, patch the system, and learn from it. It's a continuous, automated cycle of attack and defense. And that leaves us with one final fascinating question. In a future where one AI can be trained to be the perfect attacker and another AI can be trained to be the perfect defender, who actually wins? Is it the one that's faster, the one that's more creative, or is it just an endless stalemate where the advantage shifts with every single millisecond? That's the question that's going to define the next decade of cybersecurity.